Hi class, this is Sir Alex again. Welcome to General Physics 1. Today we'll be discussing our lesson 5.1, which is all about work. At the end of today's lesson, the things that I want you guys to learn is for you to be able to determine work, which is done by force acting on a system. Also for you guys to be able to define work as a scalar or dot product of force and displacement. And lastly, for you guys to be able to interpret work done by a force in one dimension as an area under a force versus position curve. So all of these we'll be discussing in today's lesson. So let's begin by first talking about work. Work in physics is very different in meaning when we are talking about work in daily life. Work in physics is actually the product of force and displacement. So basically, it's force multiplied by displacement. Force being a scalar product and displacement being a scalar product as well. These two vectors, scalar vector, not product. So force being a scalar vector and displacement another scalar vector. Work is basically a dot product between force and displacement. And the dot product of two scalar vectors are basically a multiplication of both force and displacement. So work is actually equals to force multiplied by displacement. Again, work in physics is very different when we talk about work. Work in physics is very different when we talk about it compared when we talk about work in daily life. So work is only done in physics if the force succeeds in moving an object that is acting upon. As an example, here we have a weightlifter. A weightlifter is only able to do work if he is able to lift up this barbell. So as you can see, there is a displacement. There's a difference in height. So una nandito lang siya and then it increases in height. So there is a difference in displacement. Um, and therefore there is work done as it exerts a force onto that barbell. The same thing here. This stick figure here is actually able to done work as it exerts a force into the box. So it exerts a force of 12 newtons into a box and is able to move the box. And because he was able to move the box, therefore work is done. So that is the basic idea behind work in physics. So basically in real life, when we talk about work, we usually immediately think of office work wherein a person sits and types something on a computer. In physics, we don't define that as work. In order for work to happen, there should be a force exerted on the object and the object moves. So that's how we define work in physics. So having said that, let's try this example right here. Just take my pen. So how much work is done by a shopper in pushing her grocery cart by a force of 32 newtons through a distance of 4.5 meters? So let's write our given. So in this simple problem, we are given that the shopper is exerting a force of 32 newtons onto this cart. At the same time, this shopper was able to push this cart at a distance of 4.5 meters. So what it's asking us is basically what is the work done, how much work is done. So from the discussion we've just had, we know that work is equals to force multiplied by the displacement. So in order to solve this, we just have to multiply the force exerted by the person, which is 32 newtons 32 newtons multiplied by how much distance that she was able to push the cart, while for multiplied by the distance she was able to push the cart, which is 4.5 meters. So the answer here would actually be 144 newton meter. Newton meter is the unit we use to identify work, but we can actually also an alternate an alternative okay, so an alternative unit that is also equal to Newton meter is joules. So we can also write this as 144 joules. So 1 Newton meter is equals to 1 joule. Okay, joule we usually write in terms of J. So that's how we write joule. So 144 joule is the work done by the shopper. Quite easy, right? So again, we know that there is work done because the person was able to push through the cart, and by pushing the cart, the person exerted a force. And by exerting a force, the cart moved a certain distance, multiplying the force exerted by the person onto the object to the distance the object traveled, that is equals to force. Another concept of force is if force and displacement are not parallel. So if you imagine um, the cart example earlier, so there is a person pushing onto the cart. Tama? So there is a person pushing into this cart right here. And we know that this person is pushing the cart into a certain direction. So the force exerted by the person into the cart is directed, let's say, to the east. And the cart also travels towards east. So what we're talking here is the force is parallel to the displacement or to the motion, to the direction of the motion. What if the force and the displacement are not parallel? Then what we have to do is to consider only the component of force that is parallel to the displacement. What do we mean by that? So let's take this box as an example. Let's say we exerted a certain force onto this box at a certain angle. So as you can see, the force exerted on this box is not parallel to the ground. But if you think of it, if I have this as a string and I'm pulling onto this, let's say this box right here at this direction of force, which in this case, if this is a string, is a tension. But if I pull this box towards this direction, we know that the box will still travel perpendicular to the surface it's touching. So kaya straight line pa rin yung displacement dito. Then what happens is that the force and the displacement are not parallel. What we have to do now is to take the component of force that is parallel to the displacement. What do we mean by that? Since this force is at a certain angle, so naka-angle siya, tama? But this force also has two components. It has a parallel going towards the x direction, and it has a component that is going in the y direction. So basically up and towards east. So ang kailangan mo kunin is yung component ng force na parallel sa displacement. And yung component ng force na parallel sa displacement is yung line na to. This line right here. This line right here. So we have to use this force in order to we have to find the value of this force right here, this component right here, before we can find work. And how are we going to do that? It's basic trigonometry. So we know that we have a certain angle, and since this is Fy, we can write this as Fy and this as Fx. But since trigonometry, if we want to find this, the value of this, then what we just have to do is basically get the value of the force multiplied by cosine of the angle. Then we can find the value of the Fx. I just wrote Fx here, but what you really want is the force that is parallel to the displacement. So I'm not going to use Fy in order to find work. I'm going to use the value of F cosine theta. So we will have a new equation that is derived from work is equals to force times displacement, but a little bit different. What we'll have is work is equals to Ft cosine theta. F cosine theta again is the parallel displacement, or is the force that is parallel to the displacement. Okay, and this applies to to mostly or to majority of things. No, so just remember this equation when you have a force that is not parallel to the displacement. So another thing that I want you guys to remember is that the maximum cosine of an angle is 1, and that is when cosine is equals when the angle is equals to 0. Cosine of 0 degree is actually parallel. So if these two are parallel, the angle between them is basically 0 degree, and cosine of that degree is 1. If therefore if the force and the displacement are parallel, maximum work is achieved. So when we have a situation like this, wherein the woman is, or in this case, the stick person is pushing the cart the same direction that is parallel to the direction of the displacement, then we have a maximum work done, because cosine of zero angle is equals to 1. So what we'll have here, cosine zero angle is basically work multiplied by Ft. So Ft is only applicable if the force and the displacement are parallel. Another situation that you might have is when force may be 90 degrees. So meaning we will have a perpendicular uh, we have a perpendicular direction wherein the movement of the object, so nangyayari is yung movement ng object is papunta dito pero yung force na ina-apply mo is maybe pataas or maybe pababa. Then yung angle between the two is 90 degrees, and cosine of 90 degrees is 0. Ft cosine 90 degrees, 0, that's 0, therefore the work is 0. There is no work done. So when F and D are perpendicular to each other, the work is 0. Okay, just remember that. And then there could be also a situation wherein the angle is greater than 90 degrees. So we may have a situation wherein we have, let's say, a force of going this direction, and then we have a displacement going this direction, wherein the angle is greater than where the angle is greater than 90 degrees. What happened then is work becomes negative because cosine of an angle between 90 degrees to 180 degrees, so meaning anything that is greater than 90 degrees until 180 degrees, work is negative. But what do we mean by when work is negative? Negative work means that the force is acting in the opposite direction of the motion. In this case, force retards the motion. When we say retards, is that it's kind of like slows it down. It makes it difficult to move in that certain direction. Example of those is work done by friction and the pull of gravity when you go up. So when we talk about friction, we know, let's say we have a rolling ball and the displacement of the ball is going in this direction towards east. But we know there is a certain friction that is opposing the direction of the ball. And ano nangyayari? The ball slows down. The motion is getting retarded, or the motion gets slows down, or the motion gets weaker and weaker. The same thing if you have a person going in a flight of stair, pero the gravity is pulling you down. So you have a G gravity that is pulling you down, but you are going up. So your motion is going down, but your acceleration or the pull of the force is pulling you down. So what happens is it is actually more difficult to go up than it is to go down. That is what we mean when force retards motion. That is when we have negative force. That's it. That is when the direction of the force is the direction of the force is opposite to the direction of the motion. So let's have this as an example. A boy weighing 150 newton runs up and down a flight of stairs. The vertical distance between the floor is 5.5 meters. How much work is done by gravity? So let's write our given first. We have the weight of the person. So this is weight is equals to mg is equals to 150 newtons. And this person is running up and down at the stairs. And the vertical distance between the floor is 5.5 meters. So basically the distance is equals to 5.5 meters. So what's asking us is how much work is done by gravity. So we have gravity working here. So the force is gravity. Okay. And then ano yung formula na gagamitin natin? Okay, so the formula that we're going to have to use is the formula that we just talked earlier. Fd work is equals to Fd cosine theta. So how are we going to solve this? Okay, let's first write what is happening. So we have flight of stairs. Okay, and this flight of stairs has a distance as basically has a height of 5.5 meters. So that top of the stairs is 5.5 meters. So what is happening is we have a boy that is going up the stairs while we have gravity pushing them down. Okay, so you can do this, but that will take an angle, but they did not give us an angle, so we're just gonna assume that the boy is going up, because basically they're going up the stairs. It's just going in this direction, but we're only focusing on the direction of going up. Okay, so that is the direction. So it started from 0 and going up to 5.5 meters. So they went from 0 to the top, 5.5 meters, while being forced down with the force of gravity, which is equals to 9.8 meters per second. So how are we going to solve this? So this should be weight, sorry. So it should be weight, which is equals to mg. Um, this should be, parang hindi tayo malito. This should be capital. So let's just have that as work. This would be weight. Because we both use W para hindi tayo malito. Okay, so that's W for weight, which is equals to mg, which is equals to 150 newtons. So, ano yung na-experience ni ng boy? How much work is this? How much work is done by gravity? So how are we going to solve this? Is work is equals to Fd cosine theta. We know that the direction of the movement is up and the direction of the force is basically like this. So we have going up and we have going down. And this is basically 180 degrees. Okay, so a straight line is 180 degrees. So work for A as the person goes down, A is equals to F, which is 150 newtons, multiplied by they traveled at a distance of 5.5 meters, and then we have an angle of 180 degrees. Plugging it on the calculator, you would get a negative work. And we know this should be negative work because this is 180 degrees, and that is 825 Newton meters, or basically joules. Okay, we have negative work because your motion is being retarded by the weight, by the force of gravity. Next, let's solve for P. What if the boy is going down? So the boy's weight is always going to be in going down, but this time the boy is also going down. So again, these two are in the parallel direction, the same here, but this time they are parallel, but the angle is 0 degrees. So we know that work would be FD cosine theta, and that will be work is equals to 150 newtons multiplied by 5.5 meters multiplied by cosine 0 degree. We know that is 1. That is still equal to 150 newtons multiplied by 5.5 meters, and that will give us 825 joules. And as you can see, it is positive now because they're going in the same direction. So what this tells us, it is harder to go upstairs because your weight, the pull of gravity is retarding your motion compared to when you go down. Ang mapapansin niyo yan, if you go upstairs, it is much more difficult to go upstairs if you have, flight of stairs, if you've tried climbing on a flight of stairs, than when you are going down. So that's how we compute force, especially if there is an angle involved. So just remember, if there's an angle involved, just use cosine because that is usually the parallel component of the force relative to the direction of the displacement. Okay, I hope that is clear. Let's move on with force versus position curve. Another way to solve for work done is by measuring the area under the curve. What do we mean by area under the curve? So let's take this as an example. Okay, so you have a box here and it is being exerted at a force of 6 newtons and it's traveling. Okay, so it traveled from 0 to 1 meter to 2 meters. And as you can see here, we have a force on the y-axis and a position on the x-axis. And you can graph what is happening as you push the box, no? Since constant lang naman yung force, so it means hindi nagbabago yung force mo. It stays at 6 meters as you travel. So you basically have a straight line. So how are you going to measure the work done? Usually, gagawin natin, we should just have to multiply the force, which is 6 newtons, to the traveled distance, which is 2 meters. And that would give us 12 joules. 6 times 2 is 12, that's 12 joules. Pero you can actually also use the area under the curve. So this is your curve. So curve in this scenario in graphs does not always mean na curve na ganito or curve na ganyan. The straight lines can also be considered as curves in graphs. Okay, so in this case, this is your curve, and the graph under the curve is basically, or the area under the curve is basically this area right here. And if you get the area, measure this area. Sweet. So yeah, if you measure this area ng curve mo, you can actually solve for your work as well. So why is this important then if we can just use yung equation na uh, W is equals to Ft? If I can use that, why do I need to use this? It is because in real life, the force applied on the object fluctuates. It's not constant. So yung mga ginawa natin na problem so far, the force is constant. But in real life, ang nangyayari talaga is nagpa-fluctuate yung force mo. Halimbawa dito, so you started with a force of 4 newtons and you traveled at a distance of 2 meters. And then you, in this case, basically increase the force twice. So from 4 newtons, nag-exert ka ng 8 newtons. And then you traveled the distance at the fifth. So from 2 to 5th or 2 to the third for 1 meter basically. So you travel for 1 meter, um, increasing your force from 4 to 8, and then after you reach 8 newtons, you traveled at a distance of 1 to 3 meters. So kung papansin nyo, the meters is increasing kasi you're pushing onto the object. You can imagine this is pushing onto the object. Pero yung in-exert mo force is nag-iiba siya. So here you decided to increase the force you're exerting. Pero siguro after traveling 6 meters and exerting a lot of force, medyo napagod ka. So you slowly decline yung force na ginagamit mo as you push the object. And but you still keep pushing it until after the 11th meter, nasa negative 6 meters o nasa negative 6 newtons na yung force na ginagamit mo. So what that means is the force is going in the opposite direction na. No? So this is in real life situation. The force applied on the object fluctuates and it is not constant. Okay? So how are we going to solve this type of situation na nagpa-fluctuate yung force? Ang gagawin natin is basically to solve the area under the curve. So in this case, this would be your curve. So you would have a 0 here, ting 0 mo. You would have to basically find the area here and then also find this area here. Okay, so you can do that by you can find the area under the graph by analytically using calculus and graphically. So let's do that with an example here. So the graph on the right shows the force F acting on a body versus its displacement x along the direction of the force. So along the direction of the force, meaning the force and the direction are in the same. The force and the displacement are in the same direction. So how much work is done by the force? So you started at 0 meters and a 0 force, and then you slowly increases the force that you're exerting until you traveled at 5 meters. You're already exerting a 5 meters, and then by the time you reach 10 meters of pushing the object, you're exerting a force of 10 newtons now. And then you pushed for another 10 meters. So that's 10 to 20 meters, no? That's 10 meters in total. But this time, constant yung force na ginamit mo. So in order to find the work, what you have to do is find the area. And you can do that by basically cutting yung graph mo, no? You can cut this graph right here. So this is all your area under your curve. Pero in order for you to easily solve this, you can cut this. So if I cut it this way, I'd have a triangle, and I know the area for triangle. The area for triangle is 1/2 BH. And in this case, I have, let's say, a rectangle, and we know that the area of rectangle is basically length times width. Okay, so let's have that. So this is basically your given. What is being asked is the work. And we don't have a formula because ang gagamitin natin is basically wala tayong exact formula. What we're going to use is analysis. So in this case, ang alam natin na formula na gagamitin natin is basically area for 1. In find the area of this is we have to use the equation for the area of a triangle, which is 1/2 BH. And in order to find the area for this part right here, what we have to do is use the area for, let's say, rectangle, because this is a rectangle and that's length times width. And in order to find the total work, you just have to add both areas. So work is equals to A1 plus A2. So let's solve for this. Okay, so as for A1, we know that the area for A1 is equals to 1/2 pH. So we would have 1/2. Yung base natin is from 0 to 10, so that's 10 meters. And ano yung height natin? So this is our height sa triangle, no? This is a right triangle. So this is the height of our right triangle. So we know that we have a force of 10 newtons. And as you can see, it checks out. We have Newton meters. Tama? So in this case, the work done for the first 10 meters is basically 100. So that's 10 times 10, that's 100, divided by 2, that's 50. That's 50 Newton meters or 50 joules. Paano naman sa A2? Alam natin sa A2, it's just length times width because this shape is of a triangle. So the length of our triangle is again 10 meters. So we have 10 and 20. 20 minus 10, that's basically 10 meters. So we would have 10 meters. And the width of our triangle, so the width we know is 10 newtons 10. And again, as you can see, it checks out. Kasi Newton meter is work. Newton meter is joules, and joules is work. So we would have 100 joules. So the work done here is 100 joules. Okay, so the total work done, we just have to basically add A1 plus A2. That is because the total work done is the total area under the curve. So we would have 50 joules plus 100 joules, and the total work done is 150 joules. Okay, so I hope that is clear po. So that's how we measure the area under the curve and use area under the curve to measure work. I hope it's clear. If you guys have any questions in regards to problem like this, please message me, and then do not hesitate to message me, and have a good day.